Colored pencils come in basic color packages for school children, upgraded sets for architects and other professionals, and elaborate collections of shades for the serious artist. It isn't so much the color variety that determines the quality, but the pigment concentration in the lead. The core of a colored pencil doesn't actually contain any lead. It's composed of pigments, minerals, and binding agents. This company invented a unique type of colored pencil. The lead composition is such that it allows you to brush on a bit of water after you draw to create the effect of watercolor paints. Colored pencils start with a combination of pigments. Every shade has a specific pigment recipe. They produce a large quantity of one shade at a time. Following that color's recipe, they meticulously weigh the different portions of ingredients. They boil a specific quantity of water and additives and add binding agents, a secret blend of gums, resins, or waxes. The ingredients expand in hot water, forming a paste. Workers then mix the pigments into this paste. The next machine processes the paste into fine chunks, intensifying the color. The chunks move by conveyor belt into a cylinder that compresses them, then feeds them into an extrusion machine. The extruder squeezes the paste in a continuous stream that is the diameter of the pencil lead. In a top-secret process, the next machine chops this long lead into pencil-length leads. But the leads can't write just yet. They're bathed in a vat filled with a mixture of chemical waxes. These waxes coat and impregnate the leads, in this case, red ones. Wax is a color delivery vehicle. As you write, it rubs off and adheres to the paper, taking pigment with it. With the leads now finished, the factory subjects random samples to quality control testing, including a break test and a durability test, in which each lead must yield 100 meters of writing. This company makes its pencil bodies from cedar wood. This machine carves grooves for the leads, then coats the surface with a thin layer of glue. The planks pass under a wheel that places the leads, then through another machine that slips a second grooved plank on top. The next machine carves the hexagonal shape, then slices the pencils apart. One at a time, the pencils shoot through a vat of colored varnish. Their exterior is now the same color as the lead inside. Once the varnish dries, a heat stamp burns the company name and color number into the wood, filling the lettering with colored film. Then the pencils roll across an abrasive wheel, sharpening as they go. The unsharpened end gets a cap of varnish, either in white or the same shade as the pencil lead. The factory's equipment feeds the appropriate colors to the packaging area. As the pencils slide into their grooved tray, workers visually inspect each and every one. From pigments and planks to an artistic medium, the story behind the making of colored pencils is hardly black and white. the name, the lead core of a pencil isn't actually made of lead. It's made primarily of graphite, a form of carbon that's very abundant in the Earth's crust. To produce pencil leads, they combine graphite powder with water and clay. The higher the ratio of clay, the harder the lead. Quality graphite pencil leads don't break easily and glide smoothly on the page. Graphite is mined from both open pit mines and shaft mines, like this one in Germany. Miners use hammer drills to bore holes for explosives. The chunks of ore must contain at least 30% graphite to make the area financially viable for mining. At the surface, a crusher breaks the ore into small pieces. Then, adding water and oil, they pulverize it in a rotating mill. This ore soup then flows into a system that separates the graphite from the impurities. The graphite particles cling to the air bubbles and float to the surface. Skimmers send this layer of graphite foam back into the mill. 5 cycles later, the graphite concentration is 96%. However, it's soaking wet, so it has to go into a dryer. After spinning around at 300 degrees Celsius for about 30 seconds, the graphite becomes a completely dry, fine powder. Mined and processed, it's ready to be shipped to the pencil factory. To make pencil leads, the factory combines graphite powder with clay and water. During the 35-minute mixing cycle, it's critical to control the blending speed, pressure, temperature, and moisture level. This produces homogeneous granules, the key to ensuring that all the leads will be uniform in quality. The granules go into a hydraulic press, which shapes them into a cylindrical block. Workers then wrap the block in film to prevent drying out and set it aside for a week to cure. They load each cured block into a hydraulic press, which pushes it through a forming die, producing one long continuous lead. Different dies give different sized leads. The next machine then cuts the continuous lead into pencil lengths. The leads are the right thickness and length, but they're soft and pliable because they still contain water from the mixing process. Workers load the leads into a rotary dryer at 160 degrees Celsius. 12 hours later, the leads exit the dryer straight, but not quite strong enough. So next, they go into a kiln for 10 hours at 1000 degrees Celsius. This firing transforms the clay that's mixed with the graphite, strengthening the leads to their final hardness. Finally, a 12-hour bath in a mixture of high-quality waxes. The waxes fill the pores in the leads, leaving them with a surface that glides smoothly across paper. Throughout the production process, the factory puts samples through quality control testing to check hardness, break resistance, diameter, and of course, writing quality. This company produces 3 different qualities of graphite leads in 16 different hardness levels, plus a full array of colored leads made similarly, but with pigment powders and waxes rather than graphite.